This week on the show, we tell you the tales from a core file. We have the Lenovo X260 BIOS update procedure with OpenBSD for you. We tell you a bit about the problem of Unix iowait and multi-CPU machines. We have a tutorial about a Hugo workflow using FreeBSD Jails, Caddy, and Restic. We talk a little bit about extending netbsd 7 branch support, a tale of two hypervisor bugs, and more in this week's episode of BSD Now. BSD Now, episode 346, Core File Tales, recorded for the 15th of April 2020. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Welcome back. Some people are in their castles of toilet paper. Some people are not, because they're not hoarders. Wherever you might find us, hope you are well and staying safe this way. We have headlines this week, as well as a packed episode for you. The headlines this week start with Tales from a Core File, Lessons from the Unix Standard I/O ABI, 40 years later.
So this is from noted Lumos developer Robert Mustachi, and he says, on the side, I've been wrapping up some improvements to the classic Unix Standard I/O library in Lumos. Standard I/O contains the classic functions like fopen, printf, and the security nightmare getS. While working on support for fmemopen and friends, I got reacquainted myself with some of the joys of the Standard I/O library and its history from 7th edition Unix. With that in mind, let's dive into this history and some mistakes not to repeat. While this is written from the perspective of the C programming language, aspects of this apply to all other languages. So first, APIs and ABIs. Before we dive into discussions of the standard I/O ABI, let's first talk about APIs and ABIs. In programming, many people talk about APIs. APIs define how a program can call into some other piece of code. In C, APIs are often contained in headered files, and these are documented in manual pages. For example, here are some C API declarations, extern int fstat, which takes an int and returns a struct stat or whatever, or fputc takes an int and a file pointer. The API names a function and describes the type of the parameters and the return value of the function. These declarations and dependent headers are all that one needs to write a C program. While the API is enough to write a program, when the compiler and linker get to work and you actually run your program, you need to rely on something else. The ABI, the application binary interface, describes a lot of aspects of the program that are required to have it run. For example, when you call into libc, where are the arguments found? Are they found on the stack? Are they found in registers? The ABI also describes certain things like how many bytes an int is and how should one lay out a structure with padding and so on. Now, a large amount of ABI is standardized in different documents for a given platform. For example, many Unix-based systems follow the System 5 ABI. This ABI defined many aspects of systems such as ELF, the executable and linkable format, and dynamic linking. Portions of the ABI were relegated to processor-specific parts. These describe the use of registers, the alignment of types, and more. Some of the more interesting examples are the AMD 64 System 5 PS ABI, or the RISC-V PS ABI, or the procedure call standard for the ARM 64-bit platform. These documents don't describe everything one needs. For example, while Linux, Lumos, and various BSDs all use the same AMD 64 calling convention and ELF-based binaries and libraries, there are many things that each system uniquely defines. For example, let's compare struct stat between Lumos and OpenBSD. I've placed the two side by side, though I'm trimming out a bunch of the preprocessor macros and so on. So on a Lumos, you have the device, and then the inode number, then the mode, the number of links, UID, GID, etc. Whereas on OpenBSD, the mode comes first, then the device, the inode, the number of links, UID, GID, etc. So they just changed the order of the first three arguments around. And then there's a couple other differences as well, including the OpenBSD has the concept of flags. I think FreeBSD similar, whereas Lumos does not. OpenBSD also has a birth time for a file as well. So it says, while there are a number of members which have the same types, the layout of these are such that the order of the members is rather different. There's nothing wrong with that. However, it's pieces like this that are part of each system's ABI. While these differences may seem a bit mundane at first, when you start to go further afield from Unix family systems and start, to contrast with Windows, the differences are much larger. For example, the long data type is 64-bit, or long data type on 64-bit Windows is a 32-bit value, whereas it's a 64-bit value on the Unix family. So the variable type can mean something different depending on the platform. So then we get into backwards compatibility. You might reasonably ask, why do we care about the ABIs? Well, one of the areas where ABIs are quite important is in backwards compatibility. In this case, backwards compatibility refers to the ability for today's systems to run software that was compiled in the past. If that future system can run the older programs, it is considered to be backwards compatible. A common example is how you can play your GameCube games on the Nintendo Wii. Different systems value backwards compatibility in different ways. Windows is famed and cursed for its backwards compatibility. One can run old software that targeted Windows 95 on Windows 10. Apple takes a different view entirely, and they generally drop compatibility after 2 or 3 major releases. Linus Torvalds long instilled the rule of not breaking user space in the Linux kernel, which is a similar edict about backwards compatibility for user applications. The Linux kernel doesn't have a stable API or ABI for drivers. In Lumos, we generally value maintaining a stable ABI over time so that way older software will continue to work. Maintaining this backwards compatibility does come with some costs and sometimes requires that you put forth more effort to deal with it. However, if every major update meant you had to rebuild all the software for your operating system, you can see how frustrating that would be. Lumos isn't the only system with this property. A lot of other software is also known for valuing backwards compatibility. A notable example is the GNU libc. You might ask, what does all this talk of backwards compatibility have to do with this ABI? The two are pretty closely related. Take the struct stat example above. When a C program is compiled, the offsets of the members of a struct become party to the generated library or binary. If a new member were inserted in the middle of the struct, that would change the offsets of all the subsequent members and would mean the older program would access the wrong item. The struct stat also shows another challenge with the ABI. If you look at the way that a program often uses it, it looks something like this. So they have a void function called foo that takes a path, and then they call stat on that path and put the result into a struct stat. Then they print out that struct stat.sd mode, and that will be the permissions on that file. Here the application is declared the stat struct on the stack. This means that the size of it is known at compile time and used. If we increase the size of the structure, we run a program compiled using the older binary with the smaller size of the structure, the stat call would write beyond the space allocated on the structure on the stack and overwrite the next variable and cause all kinds of havoc. With all this in mind, there's a lot we can learn from standard I/O, and in particular, what not to do. So the standard I/O was introduced in the 7th edition of Unix. Many aspects of this original version of standard I/O are the same today. The files, pointers, and fopen, getc, putc, and even standard in, standard out, and standard error were all there, even then. The now common header file, standardio.h, was introduced originally, and then. From there, it soon entered into the lands of BSD. The second BSD release in 1979 actually contained its own implementation of a small part of standard I/O. However, by the time BSD 2.9, if not earlier, it ended up with a version of standard I/O that looked pretty similar to what was in 7th edition. Eventually, the folks at Berkeley wrote their own version of it, and you can see that most clearly in the 4.4 BSD version. Lumos, due to its heritage from Solaris, was a combination of BSD and System 5 Release 4. An interesting side effect of this is that we can track most of the implementation back to the original System 5 Release 4 release. In fact, you can even see all the original AT&T copyrights in the files. Many parts of the code look similar to the corresponding version in 7th edition. Many of the file names are even the same. As a result of this particular bit of history, a lot of the ABI decisions that were made in 7th edition were carried into SVR4 and made their way into Solaris. If we look at some of the decisions with a modern eye, they're all things that make it much harder to extend standard I/O without breaking that ABI. So at the heart of standard I/O is the file structure. We'll look at a portion of standard IO.h from 7th edition Unix, and we can see that it defines the buffer size as 512 bytes and the number of files as 20. And then we have your a struct IOBuff that has a char pointer called _PTR, meaning a pointer, then a count, the base, the flags, and the file, and that's an array of the number of files of that, which is 20. So it says, well, here we go. The struct _IOBuff is what everyone knows and loves as the file structure. A lot of this structure is still with us today. If you look at different versions of the structure, you'll see the same members. The pointer, counter, and base members are used to help implement the buffer policy. The flag member is how the structure keeps track of knowing if it's open for read or write, or if you've hit the end of the file or an error or whatever. The _file member is particularly interesting. This represented the file descriptor that was backed by the file structure. If you consider a char was either a signed or unsigned byte value, this limited you to file descriptors 0 through 127 or 0 to 255. Most folks could quite reasonably have more than 256 file descriptors open. If you're writing a tool like grep, this might not be true, but if you're writing a network application and there's a file descriptor per connection, then having more than 256 connections seems quite common. So back in 7th edition Unix, the file structure were statically allocated. There was no dynamic allocation for them. And if we look at the bit above, we'll see that we could have 20 different file structures. In that world, having a file descriptor limit probably made a lot more sense than when this was first written before there was networking and so on. Unfortunately, the fact that these structures and the array were declared this way leaked into many different applications. So let's take a look at the 4.4 version of this structure, which is a bit bigger. So struct __ s file contains an unsigned char for the pointer, then an integer for read space left for get c, and then another one for how much space is left to write with, the flags, the file number, so the file descriptor, then a struct sbuff, which is the buffer itself, and then the buffer size. Then it has a bunch of pointers to the actual close, read, seek, and write functions that we used on this type of file. Separate buffers for long sequences of unget, C, and a whole bunch more stuff. And so while it's different, many things are still the same. The flags and file descriptors grew to a short variable or variable type, which let you have a bit more than 127 files open. But everything is still public, which means the layout of the structure is part of the ABI. This all leads to a few critical issues that are all intertwined. The first being the lack of opacity. If we look at the APIs that exist around standard I/O, all of them take a pointer to this file structure. This is a pointer to the file structure. This means that the use of the APIs doesn't actually require someone to know the size of that structure. Even from the beginning, the APIs that give you access in standard I/O, like fopen and fdopen, require a file pointer, and then standard in, standard out, and standard error all refer to a specific file pointer. All of this tells us that the consumer didn't actually need to know the layout of that structure. If you have a consumer where you don't actually know the layout of a structure, then we call that an opaque structure. It's just a pointer, and you don't necessarily know how the data inside that is stored. There are a couple implications to this. Most notably, it means that an application cannot allocate the structure itself. It must ask the library to do that, and that you need to use functions to access the members of the functions. While in the early days of Unix, things like binary compatibility were not top of mind, by the 90s, most systems started caring about backwards compatibility, and it was a bit too late. An existing body of software was using all of these fields directly. Many of the things that we know of as functions that were standardized in C89, such as getC and fileno, actually were macros and just dereferenced the structure member. So an example from version 7 Unix's standard io.h is, fileno just reached into that struct file and got the underbar file member. Whereas if we had made that structure opaque, it would mean the programs wouldn't, as part of the API, wouldn't have to know that. They would just call a function and it would get the right pair. And that would allow that structure to have changed without programs compiled to use it needing to be updated. And that would have probably been much better.
Yeah, this is interesting stuff.
And then they also talk about member sizing and padding and arrays and how those don't always work out well with ABIs. And then so a couple of lessons here near the end. It says, to summarize, if you're working on something where backwards compatibility is important, here are some lessons that we can take from standard I/O. Keep your structures opaque if you can. Folks can and will encode public things even if you later make them private. OpenSSL made this change as part of, I think, 1.1. And yes, we saw lots of programs that were accessing private parts of the structures and had to be replaced with functions that could do it, so that when OpenSSL changes how they lay out the data in their structures, the code in the programs that use it don't need to change. If your structure will be public, think carefully about sizing the members, because you don't want to run out. FreeBSD had lots of fun during the upgrade to FreeBSD 12 with the fact that our struct stat had to change because the size of an inode was going from 32-bit to 64-bit to allow you to have more than 4 million files in the same file system, which people were starting to do. And so that was a big breaking change that caused problems in a bunch of places, especially certain programming languages like Rust and JRuby, where they were directly accessing that struct and compiling in their knowledge of it as part of the ABI, rather than using libc to do it and having that be opaque. So he says, make sure to add room for expansion in public structures. Parts of the ABI in FreeBSD for the network stack and so on always have these padding members near the end, so that over time, like say between FreeBSD 12.0 and 12.3, when it comes out, we can add a member to a struct by using up some of that padding and won't have changed the size of the structure during the ABI stability of FreeBSD 12. And of course, think twice before exposing an array to the ABI, because you will probably regret it.
I mean, students nowadays are like, well, then I just make the data structure as big as possible, and so no one will run into any kind of limits there. But that also increases the size of the actual objects from that data structure. And
yes, remember, you might have millions of these allocated at once.
Yeah, just having one member in the array while you have a billion or how many other members is just a lot of wasted space. Oh yeah, good. It's definitely a good reading. So I would say you should definitely read the whole thing if you have time in our show notes, and learn the lessons from the 40 years of ABIs in the Unix standard I/O.
I love the little quip at the very end. He says, still, I find it helpful to remember that Roger Faulkner, a man who had to suffer with more of this than anyone else, was fond of saying, that code came from New Jersey.
I mean, it's difficult to kind of imagine how long your software will live.
Well, yes, I'm sure when they made that struct with that, where you could only have 255 files open, that they were not expecting that, people would have files that were tens of gigabytes in size or terabytes in size. And
that the software would live that long. Yeah.
Well, even, if you were Kirk and you're writing UFS, are you really thinking that somebody's going to someday try to put 4 million files in one file system?
Yeah, that's just unimaginable. Okay, a little bit more practical things in our next item is updating the Lenovo X260 BIOS with OpenBSD. So this is a fairly straightforward tutorial. Starts off with my X260 only runs OpenBSD and has no CD driver, but I still need to upgrade its BIOS from time to time. And this is possible using the ISO BIOS image. First of all, you need to download the BIOS update bootable CD from the Lenovo support website. Then you need to install the get-lterito utility with doas package_add get-lterito. Then you extract the bootable image from the ISO file. It's another doas from get-lterito -o, the bios.img, the image file, to downloads, and then the name .iso.
Right, so it's writing out bios.img by extracting it from that ISO.
Right, yeah, it's not source and target, it's both one extracting from the other. Okay, so you can see the output there, that the image has been written to the file download/bios.img. And this is what we're going to use next, in the next command, where we will copy the boot image onto a USB stick with a doas, with a DD. Be careful with DDs, with the IF and OF, not to overwrite any other important parts of your disk.
Yes, and make sure you write out to the correct disk.
Yeah. So you take the bios.img as the input file, and the output file should be your destination CD or USB stick, more like. And once that is done, you reboot the system, hit enter on the logo screen, and F12 to get the boot menu, and select the USB stick there. Then follow the wizard, and you're done. When you're back in OpenBSD, you can then check that the BIOS is now updated with call to dmesg, and then grep for the BIOS and maybe a version string or something, and then you should get the one that is in the updated, in the update utility file from the website.
Nice.
Straightforward, not too difficult. Of course, there's always a risk, yes, if you lose power during the update, and things might go wrong, but so far, so good. This is fairly straightforward and easy to do. Time for the news roundup this week. We have the problem of Unix iowait and multi-CPU machines for you.
So this is from Chris Seiberman. He says, various Unixes have had an iowait statistic for a long time now, although he can't seem to find it in BSD anywhere, and thinks it might have come from System 5. The traditional and standard definition of iowait is that it's the amount of time the system was idle, but had at least one process waiting on disk I/O. Rather than count the time as idle, as you would if you had a three-way division of CPU time between user, system, and idle, some Unixes evolved to count this as a new category, or iowait. To his surprise, iowait doesn't appear to be in BSD at all. They stick with the user, system, idle, and nice divisions of system times. iowait is in Linux and Solaris/Illumos, and appears to be in HPUX, AIX, as well as some other, the others that he found with just doing man page checks. This traditional definition makes easy and straightforward sense in a uniprocessor machine, where the system cannot be simultaneously idle waiting for a process to finish I/O and running a process. But these days, basically all systems are multi-CPU or symmetric multiprocessing ones. And in a multi-CPU world, it's not obvious how you should define iowait, because there's no longer a strict binary division between running things and stopped waiting for I/O. In a multi-CPU system, some but not all CPUs can be busy running code while some processes are blocked on I/O. If these processes had I/O that completed immediately, they could run on that currently idle CPU. But at the same time, the system is doing some work instead of being entirely stalled waiting on that I/O, which is the way iowait works on a uniprocessor system. There are all sorts of plausible answers Unix could adopt for the meaning of iowait on a multi-CPU system, ranging from the simple to the complex to the ad hoc. But no matter what Unix does, it needs to come up with some answer, and ideally document that answer. There are no guarantees that two different Unixes have picked the same answer. If you're going to use iowait to measure anything, you might want to try to figure out what it is that it means. He says, picking the answer gets more complicated if your Unix wants iowait to be a per CPU thing, like user, system, and idle time often are, because normally waiting for I/O is not naturally associated with any particular CPU. Illumos appears to not consider iowait to be a per CPU thing, per a little mention in the MP-stat man page, but does have the idea of iowait in general from the SAR man page. Another thing that often catches people out as a difference between BSD and Linux is in Linux that iowait time is included in the load average, and on FreeBSD there is no such concept, so it's not. And that means that the load average on a Linux can be really high because the CPU is really busy or because the disk is really busy. Whereas how busy your disks are doesn't impact the load average on FreeBSD. Other than, maybe your disk controller is using some more CPU or whatever.
Yeah, so you cannot directly compare the two from Linux and the BSDs. There's some other blog posts, apparently, by Chris Seiberman at the bottom about iowait and iowait statistics, if you want to read those as well. But yeah, it's a good way of knowing that these things are there, they're happening, but the systems are representing it in a different way. Okay. The next item we have is a self-hosted Hugo workflow using FreeBSD Jails, Caddy, Restic, and more. This is on Jared Wolf's blog, I'm fairly sure it is. Yeah. So Jared writes, after hosting with Netlify for a few years, I decided to head back to self-hosting. There's a few reasons for that, but the main reasoning was that I had more control over how things worked. So in this post, I'll show you my workflow for deploying my Hugo-generated website, this one. Instead of using what most people would go for, I'll be doing all this using a FreeBSD Jails-based server. Plus, I'll show you some tricks I've learned over the years on bulk image resizing and more. So there's a well-written article with a couple of screenshots and, of course, the code that comes with it. In the certain places where it's needed. So it starts off with where to host. Well, this is basically you want to host your own service, you'll need a server. That's where a VPS provider like DigitalOcean or Vultr comes in. I've been a fan, he writes, and have used DigitalOcean for a while now. After discovering Vultr, though, I've been experimenting with their platform. For this post, instructions will apply to Vultr only. Okay, I'm fairly sure you can adapt in the places where it's Vultr specific.
Yes, it's, pick a location, pick a size, click deploy, and now you have a FreeBSD machine.
Exactly, yeah. Let's start. Let's go through this real quickly. You choose the FreeBSD image, you click on that, you make it work, as Alan mentioned, and hit the deploy button, and it should appear in the cloud. Then you set up your FreeBSD server with BSD. This is basically...
Bastille is a jail manager, basically.
Yeah. So we're going basically, you set up the box, you can SSH into it, and now you're going into the actual configuration. Here we start with a few important bits using package. You do package install Restic, rsync, and BSD. We're using Restic for backups, rsync for transferring files, and BSD for the jail setup. There's a bit of section for pf.conf for blocking things and letting things through the firewall. This is all fairly straightforward and not part of this how-to too much. Of course, you enable the PF and start the service. Then you set up the BSD networking interfaces. This is LO1 here for the loopback into the jail.
Well, they're renaming it to Bastille 0 so you can tell what it's for.
Right. So that's a more recognizable name. Then you start Bastille service as well, and you create a Caddy. Bastille create Caddy 12.1 stable with an IP address of choice, and then Bastille start Caddy. I never used Caddy before, so I'm kind of excited what it is. Then install Caddy. You need to manually fetch it, or why is that necessary? There's no port yet, or what? For whatever reason, you fetch it. You get then to extract that one and copy the locations, those files to use a local bin, and then create a Caddy user to run this on with user bin sbin no login as login, so that this is just a daemon. And then you do package Caddy install ca root nss to get the certificates here. Okay, that's all you need to initialize, accept the prompts. Once you're done there, we'll move on to the next step. Once the install is complete, you can configure Caddy to start on boot. They're creating their own RCD script because that's not there's no port apparently, so you have to do this yourself. That's provided by the post. You can just copy and paste this one. Yes, you make it executable, of course, and then run this. Next, you need a Caddy file. Here's an example of one. You say basically TLS hello@jaredwolf.com in this case. You define a log location, and the root where this web directory should be shared, gzip and log standard error. Okay, yeah, the options are already explained. Further down the list here is, after you edited the Caddy file, you copy the caddyfile.conf to use a local etc. And you should now redirect your DNS to the server IP. That way Caddy can generate and fetch the correct certificates. Then start Caddy itself with BSD service Caddy start. Is that an extra Caddy there? No, one is the jail, one is the service. Okay. It's kind of confusing.
For a tutorial, maybe you should have named it Caddy Jail.
But okay, we got it.
For people like me who are confused, Caddy is the name of the web server for the Go community, apparently.
Oh, I see. Okay.
So it's the HTTPD that they're wanting to use.
Mm-hmm. Okay. Now that we have Caddy up and running, it's time to copy our Hugo-generated assets over using rsync or SCP, whatever you want to use. We're off to the next step. Make building and deploying easy. I mentioned you spend a lot of time or a ton of time programming C code, and that means I spend tons of time using make files. So for many, make is the bane of our existence. For building and deploying, make makes it easy to create reusable recipes. That way you know you can deploy it with confidence every time.
Whereas with my uses of Hugo, I just have a Git repo with I don't know, they're not sub repos. And then there's a way to tell the repo that, hey, the template is in this other repo. And then, it's just a matter of running Hugo in the root and it compiles it. And I point my web server at the output directory.
Yeah, same result. So there's it's basically all done in the make file. There's plenty of options there, but fairly straightforward for like adding images and deployment dir. Of course, you can also have optimized images there for the web.
Yep. And then they also walk through using Restic for incremental backups and how to restore those backups. So that's a good idea. And then they have their conclusion.
The conclusion reads that after you've done all the backups and it's up and running, we've covered a ton of ground on this post. We've learned how to deploy your own server using Vultr, use BSD to create container-like jails, set up Caddy to serve static file assets with TLS, deploy the files using a fairly simple makefile and rsync, backup after every deploy using Restic. And in the end, we have a robust, secure, and simple platform for hosting static files and services. Stay tuned for, there are more posts like this coming your way soon. Okay, we'll check back. And in the meantime, there are other posts as well, or just try out the tutorial for yourself and see how it went. Cool, that's pretty straightforward and not so bad as a setup. Then it's time for extending support for the NetBSD 7 branch.
So this is from earlier this week, or last week, I guess. And Maya Rashash points out typically sometime after releasing a new FreeBSD or NetBSD major version, like NetBSD 9.0, we will announce the end of life of the N-2 branch, in this case, NetBSD 7. However, we've decided to hold off on doing this to ensure our users don't feel rushed to perform major version upgrades on remote machines during the pandemic. At this time, NetBSD will continue to support NetBSD 7 so that people don't have to worry about trying to upgrade, supposed to be staying at home.
So a little bit more time to breathe. And once we're all back in the office or getting access to our server rooms again, not via SSH, that is, we can update to a newer branch. Okay, good to have. And now we have A Tale of Two Hypervisor Bugs, Escaping from FreeBSD Beehive.
By Renaud Robert. Starts with the introduction, but basically it's how they exploited a VGA emulation bug in Beehive, and then combined that with another vulnerability to be able to escape from Beehive and get access to the host machine. This is VM escapes have become a popular topic of discussion over the past few years. A good amount of research on this topic has been published for various hypervisors like VMware, QEMU, VirtualBox, Xen, and Hyper-V. Beehive is a hypervisor for FreeBSD supporting hardware-assisted virtualization. This paper details the exploitation of two bugs in Beehive. The first one, FreeBSD SA 16:32.beehive, which is a VGA emulation heap overflow, and CV 2018-17160, which is a firmware configuration device BSS buffer overflow, and some generic techniques which could be used to exploit other Beehive bugs. Further, the paper also discusses sandbox escapes using PCI device pass-through and control flow integrity bypasses for hardened BSD 12-current. So all of these bugs have been fixed for a while. Like, for example, the FreeBSD SA for the VGA emulation, that the fix was released in 2016, and the other CVE is from 2018. But this is a very detailed write-up on how it worked, and so it's quite interesting.
You don't see this very often, so that this is dissected very, very deep into the code and with explanations to show you how this was done back then. It's fixed again. But yeah, definitely a nice read-up for more technical folks.
Yes, but it is, in the end, quite long and very technical, so I'm not going to sit here and read it to you because we don't have that much time.
Yeah. But if you have a rainy afternoon ahead of you, then maybe you want to read into this.
But yes, if you're interested in just how hypervisor escapes work or what these bugs were like, it's very interesting, and I recommend to read.
All right, time for the Beastie Bits this week. We have 2 overview videos for you on YouTube. The first is about GhostBSD 20.02, so that you kind of guess or kind of get an idea what this distribution does and what it looks like and what kind of features it has. And the second is another overview, but this is FreeBSD 12.1. And so you can, if you watch them back to back, you can kind of compare them directly. But it's good to see what kind of, again, features they have and what kind of things they were built for. And I guess that gives you a better idea what they can do, and maybe you try it out after watching those videos.
Yeah, and they have a follow-up note here that some of the issues they pointed out in this FreeBSD video have all since been fixed upstream as well.
Even better.
Mm-hmm.
So you can happily skip those and just try it out for yourself and see what your experience is. Then we have a more release kind of announcement. OS 108-90 AMD 64 Mate has been released.
So this is a distribution of netbsd, if I remember correctly?
Yeah, we haven't covered it very often because they refer to the netbsd guide for installation, so it must be some derivative.
Right, we've talked about it before. I just don't remember what about it was.
Must have been a while.
But I think it's a desktop distro of netbsd, and it looks very pretty.
Oh yeah, with the screen in the background. So yeah, they got updates, and they provide, of course, the ISO image download location and checksums, and how to do some after install setup. Oh, and they provided installation tutorial video as well. Then we're kind of having a little bit of new things here. So the first thing is that PF maintainer in FreeBSD, Christoph Provost, got behind his computer and thought, let's try this Twitch thing and do some live coding here. And that resulted into the FreeBSD hacking, card panics, and test video.
So have you ever wondered what it looks like when a developer develops and tries to debug something with all the typos and everything?
Everything.
It's an interesting watch.
Yeah, for me, it was kind of like, oh, cool. I mean, I didn't understand all of it, but it's kind of like, oh, this is the tool he's using. And oh, I didn't know this command line. And oh, this switch is new to me. So yeah, and the interaction is definitely there with the community and the people who logged in during the live broadcast. And so this is kind of nice that they corrected some typos that were happening. And so you can also see, oh, I did this typo and now the code doesn't compile. And oh, why is this happening? And so yeah, this is live. This is debugging.
The one was when we caught Christoph had Linux on the brain and added like HW into an ifconfig command, thinking that you had to specify that it was a hardware address or whatever.
It's like looking over the shoulder of a developer, and I guess he will do more of those. Or if you are a BSD developer and you have another a similar thing going on for a while now or just starting out, then let us know the URL and we'll post it here so other people can watch.
Mm-hmm. Yeah, I know Ed is planning to try to do something like that. It's still very much a work in progress, but I've been working on live.freebsd.org, which is an attempt to aggregate all these streams. Originally, it was for conferences and user groups, but I've already started a Twitch section to put individual developer things in there. And I used it the other week when we had the FreeBSD office hours back on April 1st, which we basically got a bunch of developers from, source, port, stocks, etc. together and opened up to take questions from people. I think we had about 60 people show up. It was really interesting, and the video of that is on YouTube. And we're planning another one, which will probably be yesterday when you're watching this video.
Yeah, so we announced those on the FreeBSD website in the upcoming events section. And so you can follow that.
But I think the eventual idea is that we will have the website set up to actually figure out when these things start, and we'll tweet about them and so on. So that there will be a FreeBSD live bot that will note when these things start. But that's all still, in the planning stages. We're still trying to build it all. But yes, we expect to see, especially, now that we're all at home, having this kind of social thing like we did with the office hours was very nice. And I know, my user group has converted to an online one for now, since we can't meet at a restaurant currently. Yeah,
it's a different medium. And the thing that Christoph does is very instructional, and you could kind of ask questions, and you kind of like, I could do this. It's not too difficult once I see in a couple of those sessions. Or the office hours thing is like, I have this bug that's really literally bugging me. I want to have someone look at it and actually tell me whether it's a big problem or they can fix it or just give it attention. And so, or just ask questions like, hey, how does this all work? How can I become a committer or a contributor or whatever? So this is definitely made for the community and not just, see how cool I can, make these changes to the system. This is basically for the community and for learning and educating the people so that they become developers as well one day.
Yeah, and I think Dan from the FreeBSD Foundation is working on setting up a wiki page for the upcoming office hours so that people can start maybe putting in their questions ahead of time so that we can have nice answers for them too.
Oh yeah, also a good idea. So yeah, stay tuned. This is still in the making. We're probably adjusting a couple things here and there, but you can kind of see what kind of overall concept we're following.
Yeah, as we talked about in that first one, at some point we might have 20 minutes of the hour set aside for someone to do a tutorial type thing or something, or we've also talked about maybe using Mumble to have breakout groups. So that wouldn't have video or whatever, but allowing people to break into smaller groups to actually focus on, a specific topic or something. And, we're definitely open to any other ideas people have.
Yeah, it's very dynamic. It depends on the people who are there from the developer side and from the community side. And so we're kind of excited how this thing is going and what kind of things will come out of it. And definitely let us know how you think about this, or if you have your own Twitch channel where you do this like 2 years already or so, then we'll be happy to mention this in the show.
Yeah, I think there's at least a couple other port people I've seen doing Twitch once or twice. I know Steve Wills has done some stuff, although I don't know if it was actually development or if he was just using OBS on FreeBSD to stream something else. But if people have stuff, I'd be willing to bake it into the live.freebsd.org thing. And eventually the idea would be that would provide people with alerts when people go live so that, if you're looking for FreeBSD content, you'll be able to find it.
Live and can interact in ways like asking questions or, oh, by the way, there should be a comma there in this function. Whatever it is. Yeah. So stay tuned for more and drop into the next office hour or Twitch stream. Time for feedback and questions. We got a couple questions from people, but we can always use more. So if you have any questions about the BSD, the ecosystem, computing in general also, send this to feedback@bsdnow.tv, and then we'll have this section not empty in the future. The first one who did this is Shodi with a systemd question. It's a one-liner, but nevertheless important. Question for the show. About systemd. If systemd isn't used in BSD, can it be installed in a way where it functions well?
Not really. I think first of all, it's very Linux specific. It's not meant to run on other operating systems. And then even if it could, what would it do?
Yeah, it would need to have a tighter integration into the system. It's not just installing a package and it all magically works. It's just the question of how deep this goes. I mean, what does the current system not provide you that systemd would give you? There's a couple of features in systemd that are compelling, and a couple of developers looked at them and they're kind of like, yeah, we could adopt those, but it's not a complete drop-in replacement where you can say out with rc.d, in with systemd. So it really is not that BSD specific. It's built for Linux and it works on Linux. So far, so good. And it would take a significant effort and maybe some rewrites, or let's say, I wouldn't say detours, but some, let's do this thing differently on the BSDs.
My impression of that systemd is very tightly integrated with Linux, and it would be a lot of work to make it be able to run on FreeBSD, and then I don't know what you'd want it to do once it did.
There were discussions in the past about changing rc.d systems with something else, but at the moment we're using this. It works, it does its thing for a number of releases now, many years. And so some people don't have the need or don't see that the features that systemd provides are compelling enough to switch or to make these adjustments as well in the BSDs. Could all change in the future, of course, but it always takes someone who drives this, who architects this, who designs this, who implements this, so that people can play with it and adopt it eventually. But definitely, thanks for that question. And yeah, if people want to chime in or have some other comments about this, then definitely let us know. The next one is Ben with a question about Galley and ZFS or GPT as well. Goes like this. Dear Alan, Benedict, and JT, thanks for the nice podcasts. You're welcome. I find a lot of interesting things on BSDnow.tv. I have some questions for you. Sure. I have a laptop with one SSD. I have installed FreeBSD 12.1 with ZFS and Galley. These days, I decided to move the installation to a bigger SSD. My first thought was to copy the data with DD, but I have heard that encrypted disks do not do well with DD. I tried cloning the disk with a disk duplicator, an Orico external SATA to USB docking station, but with no success. On reboot, I get GPZ ZFS boot, no ZFS pools located, can't boot. I searched the net for any solution to this, but all proposed I could find to repair with gpart to enable the Galley partition with Galley configure -G. It did not help. Do you have any idea how to quickly clone an SSD with ZFS and Galley?
Cloning with DD should work. It's the resizing that'll be a bit touchy, but that's separate from the cloning. So if you just DD the whole drive to the new disk, it should still work. And it's just when you do the gpart resize, you'll have to do a Galley resize, so the Galley metadata moves back to the correct location at the end of the partition. But if you just DD'd the whole disk, the partition would still be smaller, the size of the original disk, and so it would still be in the right place. Your other option, obviously, is to, connect the second disk with that external SATA to USB docking station, and, create a new pool on it, and ZFS send from the first disk and receive to the second disk, and then, duplicate the data that way.
Yeah, so this should work.
Seems like that's what they tried in the next question. So,
yeah, second goes, I tried to ZFS send /ZFS receive the whole data from the source SSD to another machine where I have enough storage with ZFS send and receive. On the receiving side, I wanted to have the data in certain data sets, like zroot /temp/from_SSD, but I had a problem. On the sending side, the pool is named zroot, and on the receiving side, it is the same. On the receiving side, it asked to replace the existing data sets. Where did I go wrong?
So in this one, they were doing ZFS receive to zroot /temp/from_SSD. And it was asking, do you want to replace that from_SSD data set with this zroot data set? Likely all you want to do is when you do a ZFS receive for a not incremental, you want to indicate a data set that doesn't exist yet. So in the ZFS receive command, you would have done zroot /temp/from_SSD/zroot, which doesn't exist yet, and then you wouldn't have got that error.
Isn't there also an option to strip out the pool name or something in the receive or something?
There is a way to do that as well. And then that would end up with, zroot/temp/from_ssd/ whatever your data set was called without the pool name included. Yes, there's also an option for that. Although, again, in this case, that wouldn't help because the from_ssd is this empty data set you created and is asking, do you want me to overwrite it? And I can understand why you got scared thinking it was going to overwrite the entire Z pool, but it was only talking about overwriting the from_ssd data set because it exists. So in your ZFS receive command, when doing a full receive, you want to indicate a data set that doesn't exist yet, and it will create it.
Yeah, and that should not be giving you scary messages. Okay, third question or proposal. One proposal for the podcast. Can you please invite more BSD developers to tell their story, how they started with BSD, and possibly to give advice how to start coding with BSD or different coding languages? I hope it will influence younger people to start using and contribute to BSDs. Yeah, so we tried scheduling interviews. We just do double episodes in the last couple months. That made scheduling a bit difficult, but we definitely try to get back to people and, hey, you haven't been on the show for a while, or you haven't been on the show at all, and just drag them before a microphone, and before they know, we hit record and we ask questions.
We'd like to do more as well. Scheduling is a bit difficult, but we're working on it.
Luckily, with the situation nowadays, a lot of people have video cameras and recording equipment at home. So that might make things a bit easier. So we're working on this, and we'll try to hunt down a couple more people because we also want to hear their stories and their what they're working on at the moment, or how they got started with the BSDs. This is our always our first question we ask. So yeah, thanks for that feedback, and hope you got your pools copied after this, and you can continue on the new disk. All right, and then we have Stick with a do-it-yourself NAS question, or input. Goes like the following. Hello, BSD Now. Thanks for the show. Oh, you're welcome. I have been with you from the start and really enjoy my weekly dose of BSD-related news. Yeah, see, you cannot get it without it. That's how I started, and yeah, see where it got me. Okay, thanks for enjoying that and the feedback. I have a question. Besides buying a FreeNAS Mini, do you have some recommendations for a do-it-yourself NAS solution? Hardware-wise, should there be a combination of SSD and NAS drives be involved? Software-wise, I know ZFS might be the way to go, but would NetBSD or Dragonfly be an option?
So hardware-wise, the FreeNAS forums have some pretty good sticky posts about picking the right hardware, including, the non-RAID HBAs you can get cheapest off eBay and reflash to be the right kind, and so on.
The IT mode?
Yeah, to get the regular initiator mode, not RAID mode, and that kind of stuff. And also, lots of discussion. Also, servethehome.com is a forum for people with home labs and stuff. Always has, any deals anybody finds on, these particular hard drives are the best cost per gigabyte right now and are reliable or whatever. So your question of mixing SSDs and NAS drives, that will depend a little bit. You have to run FreeBSD current, I think, in order to get the new special VDEVs feature that lets you put the metadata on dedicated SSDs and the regular data on hard drives to actually try to get some value out of that, short of using the SSDs only as a cache. For that configuration, you need at least mirrored SSDs, obviously, because if one SSD dies and there goes half your metadata, the rest, having the data isn't very useful if you can't figure out which file the data is for. But yes, so a mix of SSD and NAS drives can be useful, although unless you're using very cutting-edge versions of ZFS, it can be a little harder to take advantage of those. Depending on your use case, you might not want to build for that feature yet. Like you might buy a chassis that can hold a bunch of SSDs, but maybe don't buy the SSDs until you can actually use them, because you'll get a lot more SSD for the same money by the time that happens.
Yeah.
Software-wise, I prefer vanilla FreeBSD, but you can use FreeNAS or whatever. NetBSD is starting to have ZFS support, so it might be an option. Dragonfly, you could try Hammer. I've not done that, so I don't know. But for a NAS, I really feel that FreeBSD is the best answer.
Think a little bit about extensibility. Start small, but don't limit yourself from the beginning by just having 2 drive bays or something. But as Alan said, don't buy the whole thing right now or with the latest stuff. Let it grow over time and then extend it when needed. And then you have different options, cheaper prices, and the NAS grows with you. And you, at the beginning, if you're not putting some productive data on it, you can just try out different distributions and do some maybe ZFS send and receives. So that way you get into the whole, how would this work later on when I have it in full production mode? And then once you have enough experience with it, then put the real data on it and then run with that. Okay, I hope that gave you some pointers. And yeah, good luck with your NAS setup. And so this is the wrap-up of our episode. Thank you for listening again. We'll be back next week, of course, with another episode with fresh BSD content. Stay safe, stay home a little bit longer. We'll be over the little bump here, not in our bellies, but flatten the curve is a thing. And so we'll be back and listening next week.
All right, see you next week.